Example number 2. Find 12 rational numbers between the following pairs. Just means find 12 numbers that can be expressed as a decimal or a fraction that reside between the following pairs of numbers. Now the first pair is 1.5 and 1.8. Now, in the past when I've posed this question, people have given me a lot of 1.6s and 1.7s, which is awesome. Those are two rational numbers that reside between, but then people find it really difficult to go on from there. I don't want just 2, I want 12. So the way that I can get a little bit more creative in my thinking is if I just add zeros. So 1.5 is the exact same thing as 1.5000. And 1.8 is the exact same thing as 1.8000. Now the question changes a little bit. Can you find 12 numbers between 5,000 and 8,000? You bet your bottom dollar you can. Even if I would just add 1, okay? Even if I would just add 1 0, you'd be able to find more numbers. And people would be able to see that a little bit better. So I can say 1.5001. I can go 1.6735. I can have 1.799. I can have 1.79 repeating, okay? Because that's not 1.8. I can have so many more. So what I want you to do is, for a second, well, more than a second, pause and see if you can find more numbers that fit the bill. If you have any questions, call one of us over, and we can help you out if you're in class. If you're at home, you can save your question until tomorrow. Okay, pause. Seriously, pause. And we're back! Welcome to question B part. Now this one's a little bit tricky because we have negatives. So remember, our whole negatives are flipped on its head. 4.7 in the positive, or sorry, 4.17 is bigger than 3.25 when we're talking about positive numbers, but in negative numbers, negative 1.7 is smaller than negative 3.75. But I'm going to use the exact same thing, okay? So I'm going to say negative 4.1700. I'm just going to put, some placeholders in there to help us get a little bit more creative in our thinking. And negative 3.2500. So we need to figure out a few numbers, 12, between negative 4.17 and negative 3.25. So I want to talk about a few things. Let's just put here as a boundary negative 4.18. That's outside of the bounds. Okay, and on this side, negative 3.20 is on this side. Okay, so that means that any value between negative 4.17 and negative 3.25. And I just find it helpful to put these place markers on the outside because that lets us know if we've gone out of bounds. So if I were to say negative 4.1701, I know that that would actually be closer to negative 4.18 than it would in this interval. So I don't want to go past that. So I can say negative 4.16, I can say negative 4.15, I can say negative 4.1, I can say negative 4. Okay, so now let's ask ourselves the question, what about the 3's? So I know between, do you know what, I'm actually going to put another one here, negative 3. Okay, negative 3 is on the outside here, so that means between negative 3 and negative 3.25 are not in bounds. But negative 3.9, that's within this interval. Negative 3.8, negative 3.7, negative 3.75. And let's see if you can get creative with the remaining 4. You can pause it. No, really. Do it. So I'm going to give you an example summary this time. If I were to be writing a summary for myself, I would say that rational numbers can be expressed as decimals or fractions, and can be placed on the number line. Remember, negative numbers are a mirrored reflection of positive numbers. Now that's going to make a whole ton of sense to me. Okay, these summaries are the way that you summarize this information by saying negative numbers are a mirrored reflection of positive numbers. That to me tells me that while negative 2 is less than negative 1, I know that positive 1 is less than positive 2. So they're mirrored. It's like a whole mirror is put up here, and negative 2 is the smallest, is smaller than negative 1. But here, positive 2 is bigger than positive 1.